Hi there, this is a quick update on a power amplifier I built for my FY6600 function generator. If you have not seen it, I recommend watching it first, link in the description. Here you see it on my bench or rather equipment shelf with the FY6600 on top doing a little amplitude sweep of a 50 Hz sine wave to drive the vintage meter on the right. Although the amplifier looks the same as before, I did some mods to make it more stable before integrating it into my setup. These changes is what this video is about. I did these changes some time ago, but other videos kept me busy. Well, better late than never. The main problem with the old setup was that at higher loads the amplifier tends to overheat quickly, so the thermal protection kicks in. The heatsink that comes with it is woefully undersized. Even at full fan speed the chip gets too hot. At the same time, I noticed that the rectifiers hardly get warm at all because their heatsink is way oversized. The idea then was simply to reduce the rectifier heatsink and use the space to make the amplifier heatsink larger. Now, if you try this yourself, I have to warn you that the original heatsink is apparently put on with thermal epoxy. I spent at least 2 hours trying to get it off and probably another hour scraping the leftovers from the chip. One thing I wondered right when I saw the module for the first time is why they did not remove the PCB area under the heatsink. That would have seriously improved airflow through the ribs. Because of the black solder mask, it's not easy to see if there are any traces running there. In the end, I decided that cutting would be fine. So here it is, cut to improve airflow. The new heatsink is repurposed from an old PC. I trimmed it slightly at the bottom because it is wider than the original. It overlaps the second power LED and its resistor, and it has to stay clear of these. Obviously you can't see the second LED anymore from the top, but that can't be helped. The hole on the top is to hold the temperature sensor for the fan controller. The new heatsink is a lot larger than the old one. The new heatsink installed on the board. I used thermal paste, not epoxy, for the contact area between the chip and the heatsink and drilled the holes and threaded them to reuse the original screws. The benefits to airflow improvement caused by cutting away the PCB area under the heatsink fins is clearly visible. With that sorted, it's time to fix the rest of the amplifier. It is quite obvious from this view of the old design that the op-amp with a new heatsink would never fit into the original space, largely because of the rectifier heatsink, but also because of the distribution block. Here's another shot where the distribution block is better visible. I was never quite happy with that location because the wires can easily touch the hot heatsink and they also block some of the airflow. I cut the new rectifier heatsink out of a simple 1.5 mm thick sheet of aluminium. No cooling fins or similar extensions. The reduced thickness means it can now hold the distribution block on the other side, which clears the airflow path. The new module with its larger heatsink fits easily after these modifications. And the closer proximity and larger area means the fan is far more effective too. And that's all there is. I have not found it necessary to change anything else, at least for now, which makes this video refreshingly short. Don't forget to subscribe if you not have already, and maybe consider becoming a Patron, link in the description. As a Patron you get early access to videos, blogs and other exclusive content. Thanks for watching.